So the board that you are using, just handle that. It's a D1 ESP 8266. It's a D1 wireless, and that is the latest version. So these are the parts of Arduino RE. The older version, the version which I have used, the local sensor. At the top, the far left, we have 7 to 12 DC input, just normal adapter, whereby you can power this device after you program it. On your far right, there's a USB port to computer. You can ignore the Atmega 16U microcontroller, USB controller. Those are just components which make the Arduino work. And then on your far right, you can check with your board, the blue board that you have a D1. It's slightly different from this, but we'll be able to do a review on that. So what we have a serial clock, we have a serial data. When I say a serial clock, when you're analyzing data and when you're collecting data, you'll find there are times that you have data, but you don't know when that data was provided. And that is why we have a serial data and we have a serial data. Serial data and a serial clock. So on the lower edge, we have SCK, which is a serial clock also. And the lower part, we have a master in, slave out. Most of them, they're written in abbreviations in all those components that you have. You can check the pins. And then after master out, slave in, we have an SS slave select. On the lower very part on my right, we have interrupted 1, interrupted 2, and you have TXD and RXD. I'll explain the ports and how they operate. On my left, we have an open port. We don't use it much time. And the entire left-right column, the entire column is it's a power board. What it does, oh, okay. So this board, the entire area, what it does, it powers all those accessories that you have. It has a 5-volt voltage. You have few sensors that you'll be using 5 volts. You have 3.3, like MQ4, which is a methane gas sensor. You'll be able to provide power on this. And then we have grounding. We have 2 options of grounding. You can use, depending on the number of sensors that you're putting them together, you can also connect that. And then this part, we have an analog in. Analog in, we have 3 essential pins that we usually use to communicate to sensors. And we have an SDA and SCL, which is a serial clock. All these 2, the lower 2, they return data to the Arduino. They return communication to Arduino so that the Arduino can display the data. So that was the older version, but what you have on top of the table, this is the ESP8266, a D1 wireless 802.1 series. So this version is it's a bit advanced from what you've been using previously. And this component, you can check on your boards. This component, we will power all those ESP8266, and you can put on your Wi-Fi modes of your phones, and you'll be able to see the Wi-Fi mode for the ESP8266, whereby you can be able to match and to communicate to the ESP8266 wireless 802 series in a version of a purple layer. Most times when you are doing a setup for a purple layer, you'll find you can see the purple layer, a Wi-Fi module on your phone, for those who have done a setup for that. So the same way works with this version of this this version of a PCB board. So these are on my right, far right, these are all communication ports, and on my left, all these versions, there are power options whereby you can use. You'll find an SD module card, SD module slot uses 3.3 volts, and you'll find another one using 5 volts. So depending on what you find, it is what you use, what is provided in this board. So when you go online on your laptop, you can check on Arduino IDE. You can search it, you'll find it, and you can download it. It's very easy. And then when you download the Arduino IDE, this is it. You'll find a provision on how you do the code writing, how you program it. I know most of us, we have a good number of people who can do the programming, communication programming, whereby on the lower upper end, there are the libraries that you'll be using in every component that you add to IDE. With your kit, I think with your kit you can look at a big screen inside the kit. So inside the IDE, you have to declare what will be the LCD displaying when you write the code. Initially, the portions that you'll have to use initials, you can then, there's a provision name of BME. You can write a BME for humidity and temperature and altitude. You can just write BME to 80.8, whereby when you go to the tools, you scroll on the tools. I'll do a small demo on that, on how you choose the items that you have so that you can add them in the Java. One thing you'll have, the edict that you're going to have while using this Arduino IDE, for those who have used it, every single component that you add, you're going to need a library. This IDE software has all the library. Sometimes it will refer you to GitHub. GitHub, they have also consolidated their libraries inside the IDE. I'll do a small demo on how to add on. So that is the Arduino software, the way how it works, the precision on how to use it on Windows, macOS, and Linux. Okay. Interfacing micro SD card module, interfacing micro SD card module with Arduino data logger. So we have included an SD module in your kit. Most of the sensors that you insert SD cards this is the actual way how an SD slot looks like. Most times you use sensors which has that provision. You can just open. You can open. Tear the paper, open and look at the pins. This one. Yeah, you can just open. Yeah, that one, will turn. So most times we use sensors which have this SD module card. which is very essential in collecting data. If you do not have an SD module card, how will you go on and collect data? Okay. So in the micro SD module card, which is connected to Arduino, it has a provision for VCC, which is the power option. We have GND, which is a grounding pin. And we have a master slave out, which is an SBI output for Microsoft. And we have a master slave out, which is an SPI input. We have a serial clock, SCK, and we have SC chip select. I'm going to explain very key roles on these abbreviations, because most times you're going to find them in your sensors. Maybe you're trying to put them together in your workshop. Make sure every given time that you are unable to see your data, make sure your VCC is well connected, is not weak. That is what powers the SD module. And you make sure GND, which is the grounding pin, is well connected to the SD module, so that the SD module can be seen by the other sensor. And then if you find the SD module is on, you are able to collect data, but you cannot store the data. The key part is the chip select pin is a control pin that is used in selecting one or a set slave device in the SBI bus. Entirely. You need a chip select so that it can be able to select the data and to store the data in the SD module. So I know it's a bit small, but you'll be able to see slightly. So this is the circuit. This is the interfacing of the SD module with Arduino. This is what I have provided, but it's slightly, thank you. It's slightly bigger, but most what you're going to find in the market, it's what I've just provided in your kit. So it has a provision of VCC, as I told you. You can see the connection, you can see the grounding, and you can see all the other parts of the SD. They are well terminated from the SDA, RES, TFT, MISO, SCL, all of them, they are well connected to the Arduino. I'll share with you the screenshots, the slides, so that you can check on your own time. Maybe if there's something that you can do on how you're going to put them together. So that is the sequence on how any given time you can collect data with Arduino. Arduino has been in the market for a quite big time, and most people don't use it too much because they don't understand the way how it works. But it will give you the data that you really want. I have a sensor here, which I have connected Arduino with an SD module, with a BM280 for temperature and humidity. It's going to circulate around, and I'll ensure that you power the boards that you have, the blue boards that you have, and check on how it responds. So what it does, it's a short display. The green one shows the Arduino is on, the green one, okay? So the blue one, the moment it blinks, the blink, it's very fast. So it gives you an indication that the data is being stored safely inside the SD card. So we are going to interact with it and maybe probably even open and see the way how it's working and how the data is effective. So inside the enclosure, there's RTS. So we are going to check on what does RTS